తెలిసినాడా? Hi students, before I start with this lecture, would like to urge to you that before watching this video, please watch the part 1 video on properties of nanomaterials, as this particular video is a extension of previous video. The link of that particular video is provided in the description box. From the previous video, it is amply clear that most of the nanomaterial properties varies significantly when compared to that of bulk materials because of two very important concepts, that is quantum confinement and surface to volume ratio. Accordingly, based upon these two important concepts, I am going to explain the properties of nanomaterials. So, without wasting much time, let us dive into the topic. First, let us discuss the electrical properties of nanomaterials. In bulk materials, the energy levels of valence band and conduction band are continuous, whereas in the case of nanomaterials, the energy levels of valence band and conduction band are fully discontinuous or discrete, due to which conductivity in nanomaterials is altered. In some nanomaterials, conductivity is increased, and in some nanomaterials, conductivity is decreased based upon the size, shape, and nature of the nanomaterials. Now, coming to the second property of nanomaterials, that is catalytic property. Before going to see the catalytic properties of nanomaterials, I would like to throw some light on basics. First, what is a catalyst? It is a substance that speeds up the rate of a chemical reaction but is not consumed during the course of a reaction. Now, what is the quality of a good catalyst? A good catalyst is the one which needs to absorb the reactant molecules strongly on its surface. Now, observe this figure keenly. You would have noticed that the catalytic mechanism is taking place on the surface of the catalyst. So, we can say that catalytic mechanism is a surface phenomena. Based upon this, we can say that more the surface area on the catalyst, more effectively or strongly the catalyst can absorb the reactant materials, reactant molecules, and show its catalytic property more efficiently. And from the part 1 of this video, it is very clear that surface to volume ratio for the nanomaterials is high, because of which nanomaterials are the very good catalysts. Now, coming to third property of nanomaterials, that is mechanical properties. Now, let us discuss the mechanical properties of nanomaterials. Nanomaterials have excellent mechanical properties due to their unique volume, surface, and quantum effects of nanoparticles. And as we know that the nanoparticles are smaller in size, these small sized nanoparticles, which are a part of nanomaterials, will refine the grain to a certain extent, forming an intergranular and intragranular structure, thereby improving the grain boundaries and promoting or enhancing the mechanical properties of materials. Now let us discuss about fourth property of nanomaterials, that is magnetic properties. In nanostructures, as the size of the particles is small, the magnetic moment of each atom will interact with the magnetic moment of the other atoms. Hence, all the magnetic moments align in one direction with respect to some symmetry axis of the cluster, thus improving the magnetic properties of the materials. So this is about magnetic properties. Now moving to fifth property of nanomaterials, that is thermal properties. The melting point of nanomaterials is less than that of bulk material. Why it is? Just see this figure. This is the situation of particles in bulk materials. This is a situation of this is the situation of particles in bulk materials. Bulk materials. If you bulk materials, if you see this figure keenly, if you see this figure keenly, how the particles in bulk materials are oriented. Particles are surrounded by equally sized particles. Equally sized particles. Since each particle is surrounded by more or less equally sized particles, the interactive forces of one particle with the other is more, and as the interactive forces between the particles is directly related to melting point. Melting point of bulk material is more, and if you see this figure, the right sided figure, in this nanomaterials are oriented or nanoparticles are oriented. Particles are surrounded by unequal sized particle. For example, if we take this nanoparticle, it is round in shape, spherical in shape, and it is surrounded by cylinders. Similarly, let us take another nanoparticle which is surrounded by cylinders. So based upon this, we can say that in the case of nanomaterials, particles are surrounded by unequal sized particles. Therefore, the interactive forces of one particle with the other particle is less, and as the interactive forces between the particles is directly related to melting point of nanomaterials is less compared to that of bulk materials. Now moving to sixth property of nanomaterials, that is optical properties or color. When the light is incident on the nanomaterials, it can be absorbed or scattered. If the size of the nanomaterial is less than 20 nanometers, absorption is significant, and if the size is greater than 20 nanometers, scattering is significant. Thus, by designing the nanoparticles of different sizes, optimal amount of absorption or scattering can be achieved. This may result different color for the particles of different sizes of nanoparticles. Example, opaque substance at the bulk level become transparent at nano level. Example, copper. Copper is opaque at the bulk level, but it is transparent at the nano level. And when nanomaterial is irradiated with UV light, emits visible light. If the size of nanoparticle in nanomaterial is more, then these particles will absorb at higher wavelength. If you consider VIBGYOR, these nanoparticles will look red in color. On the other hand, if the size of nanoparticles is in nanomaterial is less, then these particles will absorb at shorter wavelength and appear blue in color. Because of this reason only, the same nanoparticles of different sizes will appear different in color, which is evident from this figure. Upon decreasing the size of cadmium selenide, the same cadmium selenide is appearing in different colors. When the size of cadmium selenide is 5.5 nanometers, its color is red. Upon decreasing its size, it has been converted into brown in color, followed by light green in color, followed by light blue in color, followed by light blue in color, followed by strong blue in color, or strong or hot blue in color. Right? So this is about the optical properties of the nanomaterials. So coming to the last property, that is chemical properties. So in the first part, I have clearly explained that in the case of nanomaterials, surface to volume ratio is higher. Because of large amount of surface to volume ratio in nanomaterials, more amount of material comes in contact with surrounding materials very easily, thus affecting the reactivity. So this is about the properties of nanomaterials. I hope I had made each and every property clear to you. Thank you for watching this video.